I know, life sucks. I mean, I would just drop the class if I were you. Okay, so theoretically, a lot of what we're going to do today is review. Theoretically, you've seen most of this stuff before. However, maybe not. And even for the things that you have seen before, I'm going to ramp it up a little bit and make it a little bit more interesting. So we'll start with something simple. If I can get my clicker to work. All right, what the heck? It's a good thing I'm recording this. That's good. Why isn't this? Anyway. All right, so let's do this. Hey, what's a midpoint? Eric?
A point in the middle.
Well, it's not horrible. How we feel about that? A point in the middle of what?
A point.
A point in the middle of a point? You can't. You can't have the middle of something that has no size. Well, you're kind of on the right track. Oh, it's working. Okay, so here's my picture. I've got a segment here, PQ, and I've got M labeled as the midpoint. So Henrik said it's a point in the middle. And I said, the middle of what? And Henrik responded with something that doesn't work, but I would ask him to rethink his response. And a point in the middle of what?
Line. Line.
How long is a line?
Infinite.
Could you find halfway to infinite? Okay, so let me ask again. A point in the middle of?
Line segment.
Beautiful. But before you write that down, are you okay with that? You understand what he means? Okay, so Henrik, back to you. How many midpoints does a segment have?
One.
Only one?
I think so.
Good. How many points are between the endpoints?
Infinite.
Good. Okay. So we're talking about subsets here. All midpoints are between, but not all points that are between are midpoints. One and only one midpoint, a lot of points in between. And that analogy we'll use a lot, and I use the example of a golden retriever. Okay. Are all golden retrievers dogs?
Yes.
Yes. Are all dogs golden retrievers?
No.
No. So that comparison of sets within sets is going to pop up a lot in this class. All right, so everybody's got the definition of midpoint down? Yeah? Any questions? We're good? We all agree? Excellent. So, in that picture, I've got M being the midpoint of PQ, and I put my little tick marks in there to show that PM, Puma mongoose, is equal to mongoose quail. All right, so then I have some follow-up questions here. What's the relationship God, you'd swear it's Monday. What's the relationship between PM, obvious question here, what's the relationship between PM and MQ?
Congruent.
Say again?
Congruent.
They're congruent, they're equal. Beautiful. Okay, change colors. What's the relationship between Puma mongoose and Puma quail? Allie? Excellent. Or no, I don't care about MQ. There you go. Okay. So we get at least 3 relationships in that picture alone. The 2 halves are equal to each other. One of the halves, it's called a half because it's half of the big thing, or the big thing is twice one of the smaller guys. And you can see where this is going, because eventually we're going to set up some algebraic equations and take a look at these problems. Okay, so if I put this, let's back up here. If I took that segment and I dropped it on a coordinate plane, then we would know where P and Q are coordinate-wise, and then we can find the midpoint coordinate by using the midpoint formula. So what some of you are going to do is you're going to just write down that formula at the bottom, which you might remember from algebra, without an understanding of what you're doing. That's fine. And then you'll make some mistakes. What kind of mistakes will you make? Well, you'll turn the plus sign into a minus sign because you're used to doing minus when you do a slope. Or you'll do x1 plus y1 divided by 2 and x2 plus y2 divided by 2. What I would encourage you to do, however, is to understand what we're doing. To find the midpoint of a segment is the average of the respective coordinates. It's kind of important, that's why I made them bolded and red in there. Thomas, if I asked you to find the average of everybody's height in this room, how would you do that?
Their heights and then divided by 2.
Outstanding, well done. Okay. So for those of you that forgot how to find an average, add up the things that you're talking about and divide by the number of things. Here we have two things. We have two x coordinates. Add them up, divide by 2. And so it's an average. Any questions before we take a look at some examples? Now, again, I will continue to say it all year long. I cannot convince you to not be a memorizer. I know that's a double negative, deal with it. But I'm going to show you some alternatives that might help, because some of you have proven that your memorizing isn't working without that understanding of what we're talking about. Okay. My rant is over. Let's take a look at an example. Please find the midpoint of the segment ST. Don't be bashful. You're going to need them anyways. You might as well bust out your calculators now. I'm going to talk while you're solving. Please don't give me decimal answers. Please don't give me mixed numeral answers. Improper fractions. And it should be in the form of a point, because that's exactly what we're doing. And, last thing, and I'll let you work, even though it's fairly simple, I would still recommend making a sketch of what we're working with here. For this problem, it's not nearly as important, but if you get in the habit, when you get to the next example that I have for you, it will make your life exponentially easier. Okay, easy peasy lemon squeezy. Negative 11 halves, negative 7 halves, yes? Beautiful. Okay. And again, some of you just said x1 plus x2 divided by 2, y1 plus y2 divided by 2. 3 minus negative 14 divided by 2, 2 minus negative 9. I'm sorry, 2 plus negative 9, see, I did it, divided by 2 gives you the midpoint. But again, I would highly recommend that you think about this as an average versus just plugging into a formula. Now let's make it a little bit more interesting. I'm not going to give you much precursor to the next problem except to ask you to read the problem carefully and to draw a picture before you dive into the problem? Go. While I take attendance. Start. I'll start with a picture like I suggested. Do something comes to you. Walking around the room, I'm finding two interesting things. And I have two main approaches to this problem, and I'm finding people use both. Different people are using each of the two techniques. All right, let's try this. M is the midpoint. That's at 5, -6. K is one of the endpoints, which is 1, 2, 1, 2. Oh boy, 1, 2. And I'm looking for the other midpoint, which is llama, and we'll call it x, y. Okay, just for giggles, Taylor, what'd you get? Okay. Patrick, what'd you get? Okay, so Patrick is suggesting the answer might be 3, -2. Did anybody else get 3, -2? It's okay. Maybe you're a front runner, or maybe you're horribly wrong. I want to check to see if Patrick's right or wrong. How can I do that?
If you try to find a midpoint,
Let's pretend that he is right. If that is actually L, then if I calculate where M is, using the midpoint formula, I should get 5, -6. So 3 plus 1 is 4, divided by 2 is not 5. So unfortunately you are not correct, but thank you anyways, because that is exactly what I needed. Other ideas? Adam? 8, -16. Let's take that for a test drive. 8 plus 1 is 9. Divided by 2 is 4.5, not 5. Kai? 9, -14. 9 plus 1 is 10. Oh, divided by 2 is 5. Okay. Negative 14 plus 2 is negative. Oh. Okay, we found the correct answer. However, how did I get 12? Negative 14 plus. Yeah, that's a 1 comma 2. I had a little problem when I was writing that. Okay. So the question then, Kai, is how did you? No, you know what? I don't want to talk to you yet. I'm going to come back to you because I think I know how you did it, and I want to do that second. Celia, how'd you do this?
I did 1 plus x over 2 equals 5. And then I solved for x and I got x equals 9.
Well done.
And then I did 2 plus y over 2 equals negative 6. And I solved for y and I got negative 14.
Whoops. Why? Holy smokes. Amazing. Okay, good. Method number 1 is the algebraic approach, and that is she simply took the 2 components of the midpoint formula, and instead of plugging in the 2 numbers like you did for problem 1, she plugged in an x and a y respectively and solved. Excellent. Okay, now, Kai, I think you did something different, yes? Okay, so the method that she's going to talk about is what I would consider cheating. Sorry, let me rephrase that. I would not consider it cheating. Some people would consider it cheating. I consider it a very easy way to solve these types of problems. So what did you do? Okay. Did you follow that? I'll explain. The question is very simple. What do I do to go from 1 to 5? Add 4. Okay, so then I'm going to duplicate that to get x. What's 5 plus 4? 9. What do I do to go, changing colors because I can. What do I do to go from 2 to negative 6? What? Minus how much? Minus 8. Negative 6 minus 8. Negative 14. Obviously, if we do the algebraic approach, it's very easy to show work. How do you show work in the other method? Well, I just did it right there. Draw a bunch of little arky things and do plus or minus numbers to show where those things came from. Okay. Well done.
Are those the only 2 ways you could do this?
I'm sorry?
Are those the only 2 ways you could do the problem?
No, there's probably a lot of other different ways to do the problem. You could, I mean, and some of them just get nastier and nastier. Those are probably the 2 easiest ways to do the problem. Okay. Any questions? We're good? Excellent. Okay, I don't really want to work all the way through this problem because I want to move on and do some other stuff, but I will talk a little bit about it, and that is I'll start with a picture because we kind of covered this already. I've got Puma as one endpoint, raccoon as another, and O is the midpoint. Whoops, not Q, O, Reedy. And I know that PR is 14x plus 2, and OR is 6 minus 3x. Okay, question number 1. How long is Puma octopus?
6 minus 3x.
Beautiful. If you'll recall, earlier in the slideshow, when Allie was helping us with that other segment, she broke it down into our 3 different parts. The 2 little parts are equal to each other. The little part times 2 equals the big part. The big part divided by 2 equals the little part. That gives you a variety of different equations to use. If I was solving this problem, I would do this. Okay. I would take the little guy and double it and set it equal to the big guy. However, you could also do take the big guy and cut it in half. Parentheses, very important here. Now, one caveat. Do you know the term caveat? Okay, learned something new today. Caveat means one warning. You cannot do this. Why not? What happens when you solve that? You get 0 equals 0. Okay, that doesn't work in this case because we generated this value. And so you have to come up with one of the other methods in order to solve that. Okay, and then solve it, distribute your numbers, solve for x, get a value, plug it back in, answer the question for P1.
How did you know they were equal to each other if they didn't have a line number?
O is the midpoint of segment PR. So they have to be equal. Oh, yeah, I did do the work. Blah, 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 blah. Okay, what?
Can you go back? The last slide.
Oh, sorry, yeah.
I don't get it, because wait, wouldn't you just subtract 6 and negative 3x from the top one?
You could, but that still wouldn't tell you what x is. That would give you another expression. See what I'm saying? You still need an equation there. You could what I'm hearing you say, Adam, is can't we take 14x minus 2 and subtract the quantity 6 minus 3x? Right? Yeah. And you could do that, but that's not going to give you an equation. Okay, so what would we get here? If we do 14x minus 2 or plus 2 minus 6 minus 3x, we would get 17x minus 4, which is what this would be, right? But notice I don't have an equation yet, so I can't solve for x. All I had was an expression that I could simplify. And that is another technique. You could take that and then run with it. You could say 17x minus 4 times 2 equals 14x plus 2. You could, you got a couple of different options there. So yes, your question is valid. You can do that, but it doesn't tell you what x is. What's a bisector? Let's break it down. What does bi mean?
2.
2. What does sect mean? This one you might not know. No? To cut. So bisect would cut something in half. And the important thing about a bisector is it cuts it in half, not into 2 pieces. And I don't think I need to explain that a little bit more, but you understand the difference between cutting it in half and cutting it into 2 pieces. And it seems kind of silly to bring this up now because we've been talking about a segment bisector all block here since we started this slideshow. The segment bisector is a midpoint. It divides the segment in half. But there are other things you can slice a segment in half with. And I've got pictures of them. Obviously on the left is what we've been talking about since we started. However, the middle one, instead of just using a midpoint, I actually ran a line through that segment. So the line becomes the segment bisector. And then the one on the far right, I used an entire plane to slice a segment. There's others. You could slice a line segment with another line segment. Maybe it's not a full plane. Maybe it's just a triangle. So why do I bring this up now? If a bisector of a segment is just the same thing as a midpoint, why don't we just call it a midpoint? Because later on, we're going to be talking about different types of bisectors other than just segment bisectors. And so I wanted to introduce the term to you so you understand what we're doing here. Okay, are we good? I'll assume that's a yes. We've done this already, so quickly please fire off those 2 answers just to make sure we're all on the same page. And just as a reminder, I'm not asking you to plug it into your calculator. I'm asking you to simplify the radical. Valerie, what do you got for the first one?
6 squared root 2.
Well done. Raquel, what do you got for the second one? I'm sorry? Okay. Eveline?
2 root 5.
Well done. And Jason, last one.
Get there.
Marcel?
3 squared root
Well done. Okay. Make sure we're all on the same page there, because we are going to be doing that as we move forward. We'll be talking about the difference between an exact answer and an approximate answer. So when you simplify your radicals, those are considered exact answers. If I ask you for an approximate answer, you're going to plug that into your calculator. So just for practice, tell me what the approximate answer is for the first one. What is 6 square roots of 2 as a decimal? Just to make sure you can do that on your calculator. And let's go 2 decimal places, please. Oh, wait. Fancy. Approximately. Ben, you got it? 8.49. Good. So everybody can do that on their calculator. Yes, you found the square root symbol. Okay. Lovely. Okay, here we go. You've done this before. But let's make sure we're all on the same page. What is that yellow thing?
triangle.
It's a triangle. I'm going to proceed under the assumption that we don't need to define that right now, that you all know what a triangle is. Is that a safe assumption? Excellent. What's that little box in the corner mean, Matthew? Excellent. Yeah, you're fine. Yeah, it's a 90-degree angle, it's a right angle, it's a right triangle. Okay, here's the fun part. What is the Pythagorean Theorem? Is that you talking? Go ahead. Excellent. If you stop 100 people on the street and ask them what the Pythagorean Theorem is, some of them will look at you like you're speaking a foreign language and they'll have no clue. But those of them that do answer would say a squared plus b squared equals c squared. That ain't the Pythagorean Theorem. This is the Pythagorean Theorem. This is where we get super nerdy. Okay. No one on the street is going to say, in a right triangle, the sum of the squares of the measure of the legs is equal to the square of the measure of the hypotenuse. But that is actually the Pythagorean Theorem. But let's be real. We're going to do that. Okay. So let's go back to the actual Pythagorean Theorem and review a couple things. We talked about a right triangle already. What's a hypotenuse? The longest leg of the triangle. Of the right triangle. Only right triangles have hypotenuses. Hypotenuse? Hypotenuses. What's the plural of hypotenuse? Let's go with hypotenuses. How else can you find the hypotenuse in a right triangle? Because like in this case, I don't know distances. How do you know which one is the hypotenuse?
Opposite from the right angle.
Beautiful, it's opposite from the right angle. Okay, so if you need to find it, literally find it, it's across from the right angle. If you have the numbers, it's always the longest side of the triangle. Please tell me you did this last year. A little?
Yeah,
You didn't? Well, this is going to be fun then. Okay, so it's real simple. You're going to get two sides of the triangle. You're going to solve for the third triangle. We'll start with the easiest case. Solve that, please. Don't be bashful about busting out those calculators. You'd rather have to use the calculator for simple math than screw up on addition, subtraction, multiplication, squaring, square rooting, etc. Cornelia, what'd you get?
Oh,
13. Do you all agree?
Yeah.
Yes. Okay, so wait, let me back up. I feel I need to say this, just for my own personal sake. Are you with me? Do not ever do that. This is bad. So I'm assuming that you did not do that, and you did 5 squared plus 12 squared is equal to c squared. Math, 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 c equals 13. Exactly 13? Beautiful. This is what we call a Pythagorean triple. Pythagorean triple is a Pythagorean theorem problem where every answer is pretty. Now here's the weird thing. There are an infinite number of Pythagorean triples. Let me write that down for you because it's kind of important. Pythagorean triple. Okay, this one is called a 5, 12, 13. Now the reason there's an infinite number of them is that if I take those three numbers and I multiply them by some number, you get another Pythagorean triple. So if you were to solve it, you could have a 50, 120, 130 triangle that would still work. Or a 10, 24, 26 would still work. And there's a whole bunch of Pythagorean triples. Now, do they serve any purpose? Absolutely not. They're just going to save you some time. One of the other more common ones that you'll see, in fact, probably the most common one, is a 3, 4, 5 triangle. 3 squared is 9, 4 squared is 16, 9 plus 16, 25, we're good to go. And again, if you run into this and you see you have 30 and 40, you know automatically that the other side is going to be 50. If you don't remember that, you don't understand it, it's okay. Just think of it like a tree effect for today.
So it's
All right. What's the matter?
just to clarify, those are just memorization, that one is no.
I would call memorization. Well, yeah, I guess they are memorization, yeah.
Okay.
Yeah. Next example. Now, I do have a typo in here I realized later. It is not the shortest side of the triangle. Your answer will be bigger than 14, but less than 25. Okay? I didn't realize that until after I solved the problem. So go ahead and solve for that missing side. In other words, you're looking for one of the legs, and the hypotenuse would be 25. Be careful where you put your numbers in the equation. Isn't it? All right, so walking around, it looks like most people have either the square root of 429 or 20.71. Yes? Anybody not get those? Celia, no? Okay. So let's back up. Tell me how you set up your equation first. Yeah.
I did 14 squared plus b squared equals 25 squared.
Perfect. Your geometry is rock solid. So I'm guessing you had an algebra mistake. What'd you do next?
I took the squares,
Oh.
so
Oh, stop. Okay, go ahead. Sorry. I'll be quiet. Go ahead.
I got 196 plus b squared equals 600.
Oh, you use B instead of A. I like that. Okay. Nothing wrong with that.
And then I square rooted.
Ah! Sorry, Ben. Did I scare you? Okay. What should you do? Yeah, move the 196 to the other side. Remember, you need 429. You need to isolate the square before you take the square root. Yeah. Okay? You bet you do. All right, so here's a question. That one or that one? Which one is the correct answer, 1 or 2? Both. Right. Notice in the problem, and the way I phrased the problem, I didn't get specific as the type of answer I wanted. It doesn't say exact or it doesn't say approximate. In that case, you can give either one. If I was solving a problem, I'd just leave it as the square root of 429. However, you might want to take the square root of 429 to use it as a checks and balances. Okay? Now, what do I mean by that? Well, let's suppose I get B being the square root of 800. What's the square root of 800, somebody, real quick? $28 point something or another. What's wrong with that answer? Well, I know that this has to be less than 25 because 25 is the hypotenuse. But again, in this problem, it doesn't matter. You can give either or both. You will see, however, in a little bit, I'm going to be very specific as to what I'm looking for. It will say, give an exact answer, give an approximate answer. We'll talk about that when we get to it. Okay, any questions? We're good with Pythagorean Theorem?
Yeah.
Good. Now, Pythagorean Theorem for us is going to be a big deal. But what it's going to do more for us is act as a building block for what one of our most important topic we're going to be covering. The most important topic we're going to be covering, one of the most important, is trigonometry, which we'll get to in a little while. Okay? We're also going to play with something like this. Now, last year, I know you did the distance formula. Distance formula to find the distance between 2 points on a coordinate plane. And I'm guessing it went something like this. Your teacher gave you a formula, you memorized the formula, and then you plugged and chugged into the formula and simplified. And some of you are going to do the exact same thing. And in fact, some of you think you got it?
I don't remember that was
That's acceleration, not distance. Some of you might be able to fire off the distance formula right now because you burned it into your brain. And again, some of you are just going to take the formula that I give you, memorize it, and try to work with it. However, I'm going to show you an alternate approach, which I think will make your life a lot easier, especially since it'll require you to understand what you're doing instead of just blindly plugging and chugging. Okay, so here we go. In other words, that's my long-winded way of saying I'm going to show you where the distance formula comes from. Okay. So I'm going to start with a coordinate plane. And I'm going to put 2 random points on that coordinate plane. Now, don't start counting. In other words, x2, y2 is not at 2.5. They're just random points thrown on a coordinate plane. The only reason I have the graph behind it is so you understand that we're doing coordinate geometry. What I want to find is that distance. So x1, y1 can be anywhere, x2, y2 can be anywhere. And we're going to do a little bit of work. Now this is going to be a little tricky, but I'm not going to help you with it. So this could get awkward. We may have some quiet time for a while you figure this out. But here's my question. From the point x1, y1, I'm going to draw a vertical segment. This one happens to be red. And my question is, how long is that red segment? And before you answer, no, I don't want you to count blocks. 1, 2, 3, 4, 5, 6. No, don't do that. Okay, because again, remember those points can be anywhere. So based on the information that you see, not using the grid, how long is that red segment? Adam?
A squared.
Nope, not yet. You're jumping the gun. Told you this would be awkward.
Less than D.
I'm sorry?
Less than D.
Oh, that's not a bad answer. I got the eyebrow raised too. That's a good start. Yes, it is less than D. Now be more specific. Maybe chat with your group, see if you can come up with something. But again, we can't move on until you tell me how long that red segment is. Okay, ideas.
CB. I did C minus B.
Say again?
C minus B.
Where's C, where's B? Oh, you mean from Pythagorean Theorem?
Yeah.
Not quite. Other ideas? Taylor?
y2 minus y1.
You're so close. Did everybody hear what he said? Say it loud, say it proud.
y2 minus y1.
And again, you're so close. Marcel?
Is it the square root of x2 minus x1?
Nope.
y2 plus y1?
Nope. So Taylor, let's break this down. Why y2 minus y1?
Because if you want
Just talk. You got this.
because when like if you like the equation to find the distance between 2 points so y2 minus x2 minus x1.
But look at my picture. That's a slope. Okay, he's done the hard work, you need to do the rest of it. What's wrong with his answer? And it's minor, but relevant. Let's use the actual numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's at 10, y value of 10. And this is at 1, 2, 3. This is at 3. Therefore, how long would the red segment be? 7. So, Henrik?
Is it just a formula?
No? Kaylin?
Y2 is like actually
Okay, Bernadette?
Y1 minus
Y1 minus Y1?
Y2. Y1 minus Y2.
Bingo. Okay. You just had them reversed. If you did Y2 minus Y1, you'd get a negative answer there. Bigger minus smaller. Okay. Now, in the big picture, it's irrelevant, but the way I have this picture set up, it would confuse people. Okay? Outstanding. Hey, let's give it up for Taylor on that one. That was well done. All right, Taylor, I'm not done with you yet. So let's see if you understand everything we corrected here, and tell me how long is that blue segment? Beautiful. Well done. What kind of triangle is that?
Right?
Right triangle. And what applies to all right triangles? Pythagorean Theorem. So the way I approach a distance formula problem is I don't memorize the formula, even though after all these years I do have it burned into my brain. I approach it as a Pythagorean Theorem problem. I'll show you what that looks like in a second. But now that I have that information, I'm just doing a squared plus b squared equals c squared, where c in this case happens to be d. A happens to be y1 minus y2. B happens to be x1 minus x2. Now, this might look familiar to some of you. That's the actual distance formula. So why didn't I just give you this formula and have you plug and chug? A couple reasons. You already know by now I'm not a fan of memorizing. Number two, I have found over the years that students, this is very easy to make a lot of mistakes on. What kind of mistakes do students make? Well, they switch the minuses with pluses and the pluses with minuses. They forget to square them. They do x1 minus y1 squared equals x2 minus. So lots of different ways to screw up. But again, I know that some of you are just going to burn that into your brain and plug and chug and puke up answers. I'm going to show you a different way that I solve it based on this information. But to conclude what we just talked about, this is where the distance formula comes from. It's applying a Pythagorean theorem to a right triangle that's generated by vertical distance and horizontal distance. Okay? Everybody got this? We're good to go? If nothing else, you have the formula copied down? Excellent. Okay, so let's take a look at an example. Here's how I approach this problem. I want to know the difference between the x-coordinates and the difference between the y-coordinates. Remember, difference means subtraction. So I'm going to do something like this. -3 minus 4 is -7. That's my a term, so I'm going to square that. -5 minus -6 is 1. I'm going to square that, and what I'm going to get for an answer is d squared. Pythagorean theorem, it would be c squared, but I'm talking about distance, so I go there. I shouldn't have to say this, but I will. What's -7 squared? 49, not negative. Especially if you're going to use your calculator on that, make sure you plug it into your calculator correctly. 49 plus 1 is equal to d squared. D is equal to the square root of 50, which is equal to 5 square roots of 2. Why 5 square roots of 2? Because it says exact here. So I'm going to stop, and I'm good to go. That's an exact answer. It involves a square root. If you don't like that approach, that's okay. Then just use the formula. And in fact, what I would do is give you another example and let you solve it whichever method you'd like. Go ahead and find the different. Oh, wait, by the way, is there a difference if I go from A to B or B to A?
No.
No. Okay? Your grandma lives 7 miles from you. That means that you live 7 miles from your grandma. Doesn't matter what order you go in. Okay, solve the bottom one. Also, notice at the bottom one, Sorry, I keep talking when you should be working. You're going to need your calculator because it's an approximate answer. Hi. How's it going? Good. It's not creepy at all, is it? Why does it smell like pulled pork bacon?
Smells like salami.
Yeah. What are you eating, Slappy? You busted out a chunk of kielbasa in my class? Now we all get, did you bring enough for everyone? You have like a morning kielbasa and an afternoon kielbasa? You just got the backpack kielbasa. Just throw a slab of that in your backpack and you're good to go for the day. Okay. Oh, God. Smells like a deli back here. I'm hungry. My stomach just went roar. Can we see how much kielbasa you have with you?
I brought, so like when you buy it at the deli, they have it in like sticks, and I cut up in one,
You have half a U of kielbasa in that backpack. And you just pull it out and just
no, I
chomp an end off you have it sliced up.
Yeah.
So you are somewhat humane about that. You're not just like a barbarian just munching on a giant piece of kielbasa like a piece of beef jerky or a Slim Jim. So it's like a mega Slim Jim
Yeah.
that just stunk up my room. Oh, by the way, I forgot we're recording. This will be fun. And it's going out to the entire universe, Adam, so everyone will know that you brought a mega chunk of kielbasa to geometry and did not share with all of us. What's the answer? Victoria, what's the answer?
13.93.
Say it loud, say it proud.
13.93.
13.93. Do you all agree? Yes. Do I need to go over that? Yes? Okay, so what, Victoria, what method, did you use my method or did you use the formula? Beautiful. Okay, so I'll do this one as the formula. Distance is equal to the square root of 1 minus 6 quantity squared plus 1 minus 14 quantity squared. 1 minus 6 is negative 5 squared is 25. 1 minus 14 is negative 13 squared is 169. 194. Square root of 194, but again, since the problem says approximate, we're going to do the approximate answer of 13.93. Thank you very much. You'll notice the only difference between my approach and that approach is that I just tweaked it a little bit. This is exactly the same thing as that number. I just did it in my head. This is the same as that number. Instead of taking the square root, I just left it in terms of squares. And again, I don't care what answer or what method you use. I just want you to be able to get the answer of the square root of 194, which is 13.93. Okie doke. Beautiful. We're all done. Unlike the first 7, 9, however many weeks we spent in algebra, we're broken up into more compartmentalized chapters. Meaning, this chapter, for instance, chapter 1, only has about 5 days in it. So that means, hold on one second, let me finish this. Stop it, please.